Inverter. Inverter.
Welcome to clickmyproject.com. Let us see the project title. The title of the project is Ginix, a generalized inverted index for keyword search. Let us see the abstract of the project. In the data mining, the keyword search is the most common application for the fast search keywords over the documents. The search index method was introduced. The huge amount of new information, keyword search is critical for users to access the text dataset. This dataset includes the textual documents, XML documents, and relational databases. Users use keyword search to retrieve the document by simply typing keywords as queries. Current keyword search systems usually use an inverted index, a data structure that maps each word in the dataset to a list of IDs of documents in which the word appears efficiently retrieve the document. The inverted index for the document collection consists of a set of so-called inverted lists known as posting lists. Each inverted list corresponds to a word which stores all the IDs of the documents where this word appears in ascending order. In practice, real-world datasets are so large that keyword search systems usually use various compression techniques to reduce the space cost of sorting the inverted indexes. Compression of the inverted index not only reduces the space cost but also leads to the less IO time during query processing. As a result, compression techniques have been extensively studied in recent years. The IDs in the inverted list are sorted in ascending order by many techniques. The existing techniques such as variable byte encoding store the differences between IDs called dgap and then use various techniques to encode these dgaps using the shorter binary representations. Although a compressed inverted index is smaller than the original index, the system needs to decompose encoded lists during the query processing, which leads to extra computational costs. To overcome all these problems, the proposed system presents a generalized inverted index, which is an extension of a traditional inverted index to support the keyword search. Ginix encodes the consecutive IDs in inverted list of inverted index into intervals and adopts efficient algorithms to support the searching using the interval list. Ginix dramatically reduces the size of the inverted index while supporting keyword search with the lister compression. Ginix is also compatible with the existing decap-based compression technique. The index size can be further compressed using these methods. The technique of document reordering, which is reorder the documents in the dataset and reassign the IDs to them according to the new order to make the index achieve better performance. Let us see the flow of the project. At first, we should start the project and then the data files are loaded into the dataset. That is, the dataset is in the format of text files. So here group of files are taken for as a dataset. We should create a search index which is an optimized generalized inverted index for the keyword search for these files. So only we are considered it as a dataset. We can increase the number of documents in the dataset. Then in the each document we should remove the stop words. So the stop words in the sense am, is, was, and are, these meaningless words are removed. Then the stemming process. Here the stemming process is applied and the Porter-Stemmer algorithm is used. The stemming is performed according to this Porter-Stemmer algorithm. The stemming removes the suffixes which contains the ing, es and likewise words. So the stemming will make the words in the generalized form. Here the stop word removing and the stemming process is called as the pre-processing. So the pre-processing step is the initial step for the further processes. Here, after applying this pre-process, then we should generate the distinct words in the documents. To generate the distinct words, the whole document dataset is read. Then the separate distinct words are generated. The distinct words are generated to find the frequency of the terms. According to this frequency only, the documents are reordered. To reorder we must consider the term frequency of each term. We should generate a vocabulary list according to this term frequency. The document collection dataset is reordered according to this vocabulary word. Then the document documents, then the documents are renamed according to the reordered position. So now the interval list is created. Each word, that is the distinct word list, is prepared, then the interval list for these distinct words is created. So these distinct words and the interval list contains the search index. Finally, the search index is prepared. This optimized search index will contain the interval list only, not the ID list. Let us see the demo of the project. At first, we should select the dataset. So the dataset is in the dataset folder. We must choose this folder, and when we click the stemming button, it should perform the stemming. After performing the stemming, we can get the success message. When we click the next button, it will redirect to the next page. So here we should give the input as the stemming performed files. So here the stemmed files is given as a input. When we click the remove stop words button, it will perform the stop words, and when the stop word is removed, we can get the success message. When we click the next, it will redirect to the next page. So here we should give the stop word removes files dataset as the input. So when we click the retrieve button, the files in the dataset are retrieved. Then we should click the distinct words generation. So here in the left side, all words are displayed, and the distinct words from these all words is displayed in the right side. When we click the all, when the process is completed, we can get the success message. Here the distinct word generation is completed. When we click the next button, it will redirect to the next page. In the next page, we should calculate the frequencies of the each distinct word which is previously determined. So we should click the terms, it will get the distinct words, and when we click the calculate frequencies, it requires a dataset which is stop for removed files. So we should give the stop for removed dataset as the input. After the calculating of frequencies, we can get the success message. When we click the word, the corresponding frequency is displayed here. Then we should find the top frequency values to get the vocabulary words. We should click the top frequency values. It will show the top frequency values. When we click the next button, it will redirect to the next page. So in this page, we should file the signature scores for each files according to the vocabulary words. So to find the signature score, we should give the stop for removed files as the input. So here the file name and the corresponding signature score is shown, and according to the signature scores, we should reorder the files in the descending order according to the score. When we click the reorder files, it will reorder the files according to the signature score. When we click the next button, it will find the IDs of the word. So we should click the calculate file IDs. So when the process is completed, we can get the success message. When we click any one keyword, we can get the corresponding file IDs. The next process is the interval list creation. The interval list is created for the ID list. So here the interval list is in the three types, that is a lower bound, upper bound, and the singles. Here we should combine the lower bound and upper bound, then only we can get the intermediate files in between the lower bounds and upper bounds. The single files are the singles, and that is not in the continuous manner. When we click a word, we can get the lower bound and upper bound and the singles. When we click this button, it will show the graph. The graph represents the number of keywords in the documents according to the increment of the document size. Here in the x-axis, the number of document is shown. In the y-axis, the corresponding keywords for the document is shown. Thank you.